am Billy.
I am Lexi.
And I'm Carlos.
Done.
This is recreating our AC circuit in Multisim. First we bring in our sources, analog ground, and then we have our AC signal source, and we have our resistors, and then we'll do a 330. Connect them together. Colors our ground. There's our circuit. Our voltage supply is going to be 10 volts, 10 volt peak. Okay. And our frequency will be 1 kilohertz. Now we are going to bring in our oscilloscope. Peak to peak voltages. Of our voltage source.
Yeah, that's how you do the voltage. Also, it's only with this input, correct? This not. Let me build it and then.
Okay. And then to measure the
They got the same thing.
peak to peak voltage would be peak to peak would be 19.985 or about 20 volts. To do the RMS, we would take our peak voltage, which is 10 volts, and we would times it by 0.707, and that is going to give us 7.07 volts. And we can do that by placing a voltmeter. Here. This is RMS. 0.707 RMS volts. Now the period of one cycle is 1 millisecond, and we would take, to figure out the frequency from that, we would take we would divide the period by 1, and that would give us a frequency of 1,000 hertz or 1 kilohertz. And that was for the voltage source. Now we're going to measure the peak-to-peak voltage across R2. Peak to peak. Looks like 6.5 volts peak to peak. And the RMS, again, we will multiply 6.5 by 0.707. that gives us 4.95 volts RMS. The period here for R2 is 1 millisecond, and the frequency again is the period divided by 1, which would give us 1000 hertz or 1 kilohertz.
I'm doing the readings for new school. We going to find voltage peak to peak. Across the voltage source. Then there would be 19.6 volts. That is close to our 20 volt from multisim. Up next is VRMS. There it is, 6.65 volts. That's close to our 5 volt. 7. That's close to 7.07 RMS. Up next is time, period, and frequency. Period is 1 millisecond, and the frequency is 1 kilohertz. That was for resistor 1. Onto resistor 2. The voltage peak to peak for resistor 2 is 6.80 volts, and the VRMS for resistor 2 is 2.21 volts. The period is 1 millisecond, and the frequency is 1 kilohertz. It's the same for both resistor 1 and resistor 2, the period and frequency.
I'm going to be doing the readings for the old school method, and I'm going to start with the peak to peak across the voltage source. I'm just going to go down, make it a little easier. We're going to count up 1, 2, 3, 4 divs, and we're going to multiply that by this number right here, which is 5. That got us 20 volts peak to peak. Now our RMS is just the length of one peak, which is about 2, and we're going to multiply that by this number right here, which is 5, so that's 10. We're going to multiply that by 0.707, which is going to give us 7.07 volts RMS. Now we're going to do the period, which is just the beginning of which is just the start of one cycle to the end of it. So we're going to count 1, 2, 3, 4, 5, and we're going to multiply that by the time down here, which is 200 microseconds, and that's going to get us 0.001 or 1 millisecond. And to get the frequency, we're just going to do 1 divided by that microsecond, which is going to give us 1,000 hertz. Now we're going to move this and do the exact same thing across resistor 2. Okay, I'm just going to scale this up just so it's a little easier to read. For voltage peak to peak, I'm going to scale this down one more time. That's 1, 2, a little over 3. And then we're going to multiply that by 2 right here. It's going to give us about 6 voltage peak to peak. RMS, it's just it's about 1.7 or so. We're going to multiply that by 2, which is going to give us about 3.4 voltage RMS. Voltage RMS. For the period, we're just going to count across again from the beginning of the cycle to the end of the cycle. which is 1, 2, 3, 4, 5, and we're going to multiply by 200 microseconds, which is going to give us the same thing as before, which is 1 millisecond. And for the frequency, since it doesn't change, we're going to do 1 divided by the microsecond, which is going to give us 1,000 kilohertz.